There we go. Just got to press a little harder. So nonetheless, we'll cover a little bit about that, go through a little bit of an overview of what we can expect together here. Make sure I'm going in the right direction on my PowerPoint. Some of this, for those of you that have taken maybe one of my fall protection courses in the past, have probably seen some of these things, particularly related to this hierarchy of fall protection. And the thing about it is, when we think fall protection, a lot of folks automatically default to this idea of harnesses, lanyards, go tie off to something. Well, sure, that's a big driver of that, but there's many different elements that comprise into this concept of fall protection being a process, not a piece of equipment, not just training, not just programs and policies, but a process. It's a work process. Maybe some of you folks have ever heard of something called the OODA loop. I knew you'd look up on that one, Alex. I knew you would. OODA loop. The idea that we're constantly observing, orienting ourselves, determining the correct solutions for a particular problem, and then acting. That's the acronyms. And then we repeat that process all over again with observation, orienting, decision-making, action, OODA. And that's a continual thing that we need to do, not just in fall protection, but of course in safety. However, what I do find when it comes to fall protection is a lot of employers satisfy themselves with one solution and they go, cool, we're on to the next thing. Oh, this fall protection issue over here, we just addressed it and we move on. Where's that follow-up? Where is that OODA loop occurring over and over and over again? The follow-up to the observation and then decision-making and action and repeating the process again. It's a very critical measure in what we do. We'll get a little bit into some of the training requirements, our ABCs, of course, and rescue. And really kind of most importantly are some pretty significant changes that have happened recently as of August of last year related to our SRDs, our self-retracting devices. Any questions so far? Cool. Keep on going through this. What is any good fall protection policy, program, implementation of any particular system without a proper assessment? And really and truly, our assessments need to start at ground level, at walking surface levels, and go up from there. We can't always assume that our fall protection issues are related to human beings being at a fall exposure from a height to a lower level. And that could be from ground surface to lower level. But what about our traction properties, our walking surfaces, the surfaces I'm walking on right now? If this carpet was too slippery, I would have problems. Now, naturally, if not only is it too slippery an issue, but can surfaces be too sticky as well? You bet they can. They absolutely can. So in our 3115 class, we spend a fair amount of time talking about the coefficient of friction, tribology specifically, the concept of friction, and the walking surfaces from our work boots that we're wearing to the different floor types that we're dealing with. And then what kind of standards back up these concepts of tribology? Now, how do we measure slip resistance on our walking surfaces? Anyone want to guess? It's very technical. A slipometer. But of course, you got to have the slipometer out there. And there are devices that help us measure traction properties. By the way, about 0.4 to 0.6 is roughly what ADA considers appropriate for moderate traction environments, dry areas specifically. Next time you're at Home Depot, walk down that tile aisle. Take a look at the box of tile that you'll see printed on the side of the cardboard. It will say wet COF, and it's going to give you a number. That's the coefficient traction level. It'll give you a dry one as well. And the concept of this isn't terribly difficult. It's a fraction. It's a coefficient number. So imagine we take 10 pounds of weight, and if it takes 10 pounds of force to move that weight, we have a static coefficient of friction of 1, n divided by 1. If it takes 5 pounds to push that 10-pound object, we have a static coefficient of friction of 0.5. So like I said, somewhere around 0.6 is roughly typical for our traction properties. And those are the kinds of things that we get a little more time to explore. Now, naturally, we're pressed for time here, and there's a variety of things to go through, so we can't unpack that too far. But ultimately, do not assume that our fall exposures are always related to when our feet leave the ground. The big dangerous, how many guys here, folks, have mechanic shops, warehouses, What happens to those floor surfaces over time? They change, don't they? That traction surface property level at one point in time changes when you have 10 years worth of forklifts driving across that concrete. Certainly things to consider. When we're doing our fall exposure assessments, very important that we check for unusual areas, atypical locations where you might not otherwise expect fall exposures to occur. And these things evolve. Never is this more true on construction projects or a demolition project, where one day there's a static environment and you think that, okay, this is the present condition that we're dealing with. And then within a matter of hours, a wall system gets opened up. Or a piece of plywood that was covering a floor hole is now missing. Constant exposures and assessments. Again, this OODA loop concept is something we have to take a look at. Now, our trigger heights, and when I say trigger heights, what we're referring to is the height above a lower level by which there's a fall exposure. And those trigger heights do vary dramatically. They'll blow your mind. And this is only federal OSHA. Imagine if we include Cal OSHA in here, Washington OSHA, New York OSHA, so many of those other state programs. We're talking about trigger heights that range from 20 inches, 30 inches, 4 feet, 5 feet, 6 feet, 7.5 feet, if we include California, 10 feet, 15 feet, 20 feet, and 30 feet. And guess what? It all depends on the work environment and the type of work that the employees are doing. Now, within that concept of these trigger heights, the control mechanism for that fall protection will also vary. And that's regulation driven at the end of the day. And there's a lot of misconceptions out there about what's most appropriate for the type of fall protection system that we need to be instituting. Most folks are most familiar with our construction and general industry trigger heights. 6 feet for construction, 4 feet for general industry. Some observations here related to our edge types. When I'm out there in the industry, I hear a lot of folks not intentionally misspeak about various edge types that we're dealing with. And I hear this term used all the time, leading edge. Oh my gosh, stay away from the leading edge. It's bad. It's a leading edge over here. Understand that leading edges are not unprotected edges. They are different. A leading edge refers to a work process. Leading edge means that we're constructing something where we're exceeding, in an environment where we're exceeding those trigger heights that are prescribed by the standard. Whereas an unprotected edge is static in nature. It's just there. It could be the edge of a floor. It could be a hoist location, hoist area where you're bringing material on and you have removable gates and you have an unprotected edge location. Most of our work environments will have unprotected edges when we talk about the fall exposures. Again, leading edges refers to a work process. So what is this gentleman doing here? What's he got going on? He's doing something.
Installing the sheeting of the roof.
Yeah, so someone said he's installing the sheeting of a roof, maybe it's a floor, but he's laying down sheets of plywood, isn't he? So every time this individual lays down a new sheet of plywood, they've created a new unprotected edge. And every time you change that edge location, you are engaged in leading edge work. Now, why is that important? Good question. Glad you asked, sir. Very important you ask these kinds of questions. The reason why it's important is because the type of system that we're allowed to use depends on that edge classification. We are restricted to certain types of protection for unprotected edge environments as opposed to leading edges. And we'll unpack some of this just a little bit as we get into this topic here. So again, it's a static edge. Anyone here? Unprotected or leading edge? What is that? Anyone online can answer too, of course.
Leading edge.
Is that a leading edge or an unprotected edge? It's an unprotected edge, isn't it? It's static in nature. It's not moving. We're not constructing anything that's changing that edge location. Therefore, guess what? That means to us that for unprotected edge, the only fall protection control mechanisms available for us to use are conventional systems. Conventional fall protection. Conventional fall protection are things like guardrails, covers, fall restraint, fall arrest, or safety nets. I neglected some things in there, didn't I? Presumably, that is. What about warning line systems? What about controlled access zones? What about safety monitors? What about OSHA written fall protection plans? Well, guess what? Those are administrative systems. Administrative systems are not something that we use to protect workers from unprotected edges. Administrative systems are available for us to be used in leading edge environments. There's a difference, and there's a reason for that. This concept of moving edge. And by the way, leading edges aren't just moving horizontally. They can be moving down, they can be moving up. In the scaffold industry, we're engaged in leading edge work every darn day. Because every time I add another scaffold level to our assembly, I've created a new unprotected edge. And then I add another scaffold level, I created another new unprotected edge. And again, that's leading edge work. So we're engaged in this concept of leading edge work activities. Has anybody ever heard someone say, oh, scaffold workers don't have to tie off because they have unique rules? Has anyone ever heard someone say that before? I know I have. I see by your smiles in the room that you have too. What folks don't realize they're alluding to is they're alluding to this idea that this work operation is a leading edge work process. And consequently, there are some unique, let's say, allowances for the protection systems that are chosen for that environment. And it's not that, by the way, scaffold guys don't have to tie off. Wish we had time to talk about that. That's about a 4-hour topic just in and of itself, incorporation of fall arrest system with scaffold builds. But I digress. And that's what we have going on here. This guy right here is building a scaffold system. It's a cantilevered scaffold system. Notice the gentleman is tied off, engaged in leading edge work. Chains, hoistways where there's removable chains, removable guardrails. These environments that are under flux and change constantly. Well, as soon as we change that mechanism of fall protection, we need to do something else, don't we? So you remove that guardrail to bring a forklift pallet on, to land a bundle of rails onto an elevated surface somewhere, and you remove those guardrails. Well, what are we going to do for the workers who are needing protection now? Any ideas? What will be our next step once we remove those guardrails?
Fall restraint.
There we go, fall restraint. That would be far more preferred than fall arrest. Mention this, reasons why here in just a few moments. And by the way, as we're going through some of this stuff here, I went ahead and added some of our reference sections for you folks, both online and in person here, to observe. If you're curious about the specific standard that backs up some of these broad concepts, that's what you're going to see. Now, naturally, 1910 means general industry. 1926 refers to the construction industry standards. This applies to ramps, elevated walkways, all of which have different trigger heights. Now, this photograph that we're observing here is almost a darn near perfect example of what a proper environment should look like to protect workers. However, there are some issues here that can be touched up, tidied up, and made a little bit safer for workers. Now, coming out of the field myself, it's easy for me to put myself in the perspective of the worker who's out there doing this stuff and recognizing these potentially dangerous conditions. Try to do that, because in my mind, what I imagine is me as a first or second level apprentice carrying 2 or 3 planks on my shoulder, which is going to be about 100 to 150 pounds of weight. And it's going to be 7 in the morning on a spring day. So there's dew and moisture across this ramp surface. And here I am trying to go to work. And I got to walk across this pan deck right here, this Robinson decking, this metal corrugated steel that we see right here. Incredibly slippery. The general contractor laid in a rebar mat, so now you're stepping through that. And you know what good workers do? They just do it. They don't complain. They don't push back. They know what they're up against. And all they know is they got to get scaffold on that wall over there, and it needs to be done now. So what are we going to do about that? Are we going to advocate for that worker when we know there's environments like this and the construction phasing doesn't allow for a more favorable environment? Or do we turn our head the other way and just accept it for what it is? Kind of a slight digression. That's one of the reasons why I'm really proud to be part of Commercial Scaffold. I had to inject my logo down in the right corner of my presentation down there, of course. Shameless plug, of course. But man, it's cool being part of a company where I get to drive our production, our quality, our efficiency, our response, and our safety. And coming from the background that I do, I have a very great appreciation for safety. There's probably not many business principals out there that have stood next to a worker in the hospital with his family standing around them. There's probably not many business owners or principals who have showed up to a job site somewhere because somebody fell 35 feet off the scaffold equipment and there they are laying in a big pool of blood. And you got to deal with that. I have, and it sucks really bad. So when my safety director comes to me and says, hey, I want to do this. Cool, let's talk about this. How are we going to figure this out? How are we going to accomplish your goals? And naturally, as a business principal, you're sensitive to costs. That's what you do. You got to make a functioning business. But I'm proud to be a part of that background where I have that perspective going, you know what, this is the right thing to do because it's the right thing to do. And I'm pretty well known for saying in my company, there's not anything we won't do to make money, except for put humans at risk. I'll do anything. You want me to show up and paint your scaffold green, pink, yellow? Don't care. We'll do it. You want me to set scaffold near power lines where my guys are going to swing a rail into that? Not going to happen. I don't care how much you pay me. Just not worth it. Loading dock areas. Got some great products out on the market to address these environments. Anytime these docks exceed 4 feet in height, we have to have some railings in place. And that's what this dock does right here. We can see it can flip up into place. And once it does, we have continuous guardrails going across it. Lovely, lovely environments. Let's focus a little bit on our hierarchies of protection. Hierarchy of fall protection. Who here in this room has heard of the hierarchy of fall protection? 3 or 4. Oh, sir, I know you have. Been in a couple 3115s, haven't you, sir? Yeah, that's great. So many times we find ourselves here on the orange side of the column. This is our harness and lanyard stuff, our fall arrest systems, our self-retracting lifelines, our leading edge self-retracting lifelines. And we go, oh, yep, there's a fall exposure, here's a harness, there's a lanyard, tie off it. And usually when that's said, it's like, tie off and be careful. And the worker's like, oh, sure, yeah, I'll be careful. But we're neglecting the yellow, green, and dark green columns that are here. We are required as part of our, there's a standard out there called the ANSI Z359 family set of standards. We're going to be getting into that at the end of this year. The ANSI Z359 set of standards go back for many, many years. And within that standard, there's a 0.2 section, Z359.2, titled Minimum Requirements for a Managed Comprehensive Fall Protection Program. That program is going to help an organization like yours develop policies and procedures to address your workplace exposures. And in that program, we are mandated to start at number 1 here. Can we eliminate the fall exposure in the first place? And if we can't, then we start working down our steps. Passive systems, that's your guardrails. Active systems are after passive. That's column 3 here, and column 4 are your active fall protection systems. That's where, think of it like this. Number 2, passive guardrails. It's a barrier, it's sitting there, it's passive in nature. 3 and 4 are your active systems. Think of actively tying the human being to something. That's an easy way to remember active versus passive fall protection systems, all of which come through that Z359 standard that I'm talking about. And then lastly, we get down to that number 5, red column there, with our warning line systems, controlled access zones, fall protection plans, and things like that. We really need to be at level 4 or less, working through that hierarchy. Now, yes, ma'am, is there a question?
I have 2 questions.
Okay, sure, what do we got?
Do you need fall protection on a scaffold with the green tag? Is there a difference between scaffolds with cross beams and scaffolds with mid rail and top rail like a standard guardrail?
Great question. And holy moly, I wish I had hours to really unpack that question. That's kind of like a Pandora's box question. You can answer it at a surface level, but it leaves a lot to be desired. So broadly, are workers required to tie off on a green tag scaffold? first of all, let's establish what a green, yellow tag and red tag scaffolds are. In the scaffold industry, as a procedural thing, not an OSHA thing, but strictly as a procedural thing, it's common for installers to green tag a scaffold that's considered complete, yellow tag a scaffold that's as complete as possible, but for some reasons leave certain safety items behind. There's reasons for that. And of course, red tag means do not access that scaffold. So that whole concept of tagging a scaffold system in the first place is not an OSHA requirement. It's an industry procedure that's used as a communication tool for the scaffold installer to communicate to the user that, hey, this scaffold is green, yellow, red. Its particular state. Now, the whole concept with the green tag scaffold is that the scaffold's fully complete. There's no safety deficiencies on that piece of equipment, which means double guardrails, top rail and mid rail, full width platforms, proper access to that system via a ladder, staircase, or a ramp. But at the end of the day, there's no observable safety deficiencies within that equipment. And in that situation, there is no additional requirements to tie off or attach a fall arrest system to that scaffold system or somebody else, because it's a complete scaffold. Now, with that said, there are many contractors and employers who, as a policy, do mandate tie off on all scaffold systems. And this does happen quite a bit in your more industrial environments. If you go set a scaffold at Chevron, BP Arco, more of these petroleum process manufacturing facilities, you're going to find that it doesn't matter how safe and how complete that scaffold is, the workers, you're required to tie off. And that's a policy situation. That is not an OSHA requirement. Those are two separate things. What's the second?
For a second question, is there a reference guide to compare the Fed OSHA versus Cal OSHA fall protection standards?
There is, and that is a fantastic question. On OSHA's webpage, if you Google search it, it's probably the best way to find it. Or if given some time at the end here, if you would make a note for me, I'd be happy to find it and we can push it out as a link to students here. But there is a comparison guide that OSHA, federal OSHA themselves do publish, and it shows those trigger height differences between the columns. So yes, there is. We can get that for them. And by the way, back to that first question, there was like 3 questions in one in that first question. So the last part I just realized was a question related to the crosses. They were described as cross beams, but crosses that stabilize the scaffold equipment. Crosses in terms of fall protection for scaffolds are permitted in certain conditions. And it has to do with the relationship of when that cross comes together, you have that center point on the cross. It has to do with the relationship of the walking surface and the height of that cross center. That's what dictates whether or not that cross brace can be used as either a top rail or a mid rail. Never could a cross brace be used at both top and mid rail, but a cross brace can be substituting either a mid rail or a top rail, but that's cross height dependent. If you really want to get deep in the weeds, it's 20 to 30 inches in height for a cross brace. For a mid rail, 38 to 48 for the cross point of a top rail substitution. So that should answer that third question buried in there too. So elimination processes. Can we, oh, I'm sorry. Yes, sir.
Thank you. If we go back one slide, the conventional hierarchy, the red zone, do we still use the conventional fluorescence? Yeah.
I'm sorry. So in the red zone, maybe use control access.
Conventional fluorescence systems.
So are we able to use both administrative systems like what's in the red zone and tie off at the same time? Is that the question?
Are we required to use all other systems in the red zone?
Very good question. Thank you. So no, what the question is do we have to use a multitude of different systems? So in other words, if we're using a controlled access zone over here in number 5, are we also required to tie off, use restraint, fall arrest, or something like that? And the answer is no. Essentially, we can identify a total of 8 different processes or control mechanisms for fall protection. And once we do one of those, that's all we're obligated to do. So assuming we are permitted to use a controlled access system because the environment allows for it, such as leading edge work, and we have a written plan behind it, we are not required to additionally tie off all the time. The contractor might choose to, as part of a good written plan, to address little areas that might create additional exposures. But as far as the regulation is concerned, you're kind of one and done on that, if that makes sense. So elimination systems. Yes, you can do things to eliminate fall exposures. Maybe you've been in Home Depot and you've seen those little grabby devices on long extendable fiberglass poles for changing light bulbs. And so the concept is that the worker can change the light bulb while standing on that walking surface on that long pole, never having to access a ladder or a scaffold or something of that nature. This is a cocoon type system that we see in this photograph, enveloping the entirety of that building structure. Not only are we addressing fall exposures for humans, but we're also addressing falling object exposures. Falling objects are a big deal. They're a very significant contributing factor to fatal injuries in work sites. And so if we can control those objects from impacting workers below, that's a great thing. And not just workers, by the way, but the public. Maybe some of you folks recall about probably 10 years ago, there was a UPS truck driver in New York. Showed up to the job site to deliver a package. He's not wearing a hard hat. Gets out of his truck, tape measure falls off of elevated high rise, strikes him in the head and kills him. Dropped objects are a very serious issue. And keep in mind, there was a study done by Berkeley a few years ago, about a decade ago now. And what they were doing was to try to determine the projection distances for various objects that are dropped versus their dropping distance. And what they were finding were some of these ratios were equaling 1-to-1. So in other words, in some situations, especially if it's a hard metal on hard metal contact object, you drop an object 100 feet, it could potentially project out an additional 100 feet from the base of that structure. So here you are building the Wilshire Grand Tower in downtown LA that's 1,000 feet tall. You drop something from up there, it might end up on the 110 freeway. The very least, it's going to end up potentially blocks away. So now we're not just dealing with worker protection, we're dealing with some public issues as well. Certainly don't want to drop stuff like that. Not always are we able to completely eliminate fall exposures, but maybe we can minimize the duration of time that there is an exposure. And that's what we see observed in this particular series of photographs right here. We can see these roof trusses that have been fabricated on the ground and has sheathing and plywood installed on them. And then the entire unit with guardrails and all gets blown up into place. This is why it's so important for safety professionals to become intimately familiar with your own organization's work processes. You got to get down in that dirt. I always say, get your boots dirty. Stop polishing that desk in the office and go get your boots dirty. Ask questions, find out why these people are doing things the way they are. And with your expertise and the knowledge of the regulations and education like this, you'll be able to implement some good processes. And we do this in the scaffold industry all the time. We sequence our work such that we're not only relying on fall arrest throughout our entire scaffold assembly. Sometimes we're relying a little bit on restraint. Sometimes through certain phasing of that work, we're relying on arrest. But the goal is, how can we be in higher forms of controls for longer lengths of time? And so consequently, for about 80 to 85% of the time that a scaffold builder is erecting a scaffold system, they'll be protected by a passive system, guardrails. So we're minimizing the duration of time of that exposure. That is also a good thing, even if we can't eliminate it. Ask ourselves, can we move higher up that hierarchy for better lengths of time? Floor holes, a passive system. Floor holes are defined as any gap or void greater than 2 inches shall be covered. What does a proper cover look like? I'm sure some of you folks here in the room know. What does a proper cover look like? Is it just a sheet of plywood I plop down on the ground and walk away from and go, there's my floor hole cover? No? What does that look like? Roll, I know you know. Plywood, the plywood hole. It could. Good. Plywood, 2 times the expected load is our cover capacity requirements. Will plywood work for human beings? Yeah, probably, depending upon the spans that we're trying to cover and stuff. You know, a sheet of 3/4 inch exterior grade plywood might get you that capacity that we're looking for. Again, it depends on the span, right? Is 3/4 inch plywood going to be sufficient for that scissor lift that needs to drive a Class 8? That forklift? That semi truck? Maybe it's a steel sheet. Maybe it's beams and plywood. Maybe it's just structural shoring system, temporary structural shoring system, and beams and plywood. All of it is why these covers shall be designed by a qualified person. And naturally, the covers, the whole floor hole covers have to be labeled as hull or cover and secured to the deck from displacement. Secured to the deck, 2 times the expected load, labeled hull or cover. Guardrail requirements, man, these things also vary. It depends on if you're looking at Cal OSHA or federal OSHA. It depends on if you're looking at a scaffold guardrail requirement or a general fall guardrail requirement. But in the context of federal OSHA under subpart M, which is where our fall protection requirements are found, we're going to see a top rail height of 39 to 45 inches. So that measurement is taken from the walking surface, in this case it would be concrete, to the top edge of guardrails. You must have a mid-rail approximately midway and a toe board. Yes, sir.
You mentioned the term qualified person. I remember in Cal OSHA, they referred to qualified and the competent person.
Yeah.
Could you elaborate on that?
Of course, of course. So in our authority of control, if you will, starting with our person who should be most knowledgeable. And in fact, that's more or less what the definition of a qualified person is. Somebody with an extensive amount of knowledge, who might have a certificate, a degree, a license, who can demonstrate their ability to solve problems in the workplace. That's almost the definition right there out of Cal and OSHA of a qualified person. A competent person, however, doesn't have to have quite the extensive level of knowledge as a qualified person, but they do need to be very knowledgeable about the work that they're doing. They must be capable of identifying those existing and predictable hazards and have authority to correct those hazards. So really, competency breaks down into 2 different basic elements, doesn't it? Knowledge and authority. You don't have a competent person without both. That's broadly speaking what these ideas of qualified and competent person look like. Now, specific to fall protection, our ANSI standards heavily cover those roles and what those responsibilities are for those roles. Now, a qualified person does certain things. And one of the things that they might do in fall protection is design certified anchors for workers to tie to. Notice I use the word design certified anchors. Now, that design of certified anchors must be performed using nationally accepted engineering methodologies. That's the term that the Z359.2 standard uses. Nationally accepted engineering methodologies. So they're not telling us you shall use an engineer, but aren't they really like going, hey, if you're going to design an anchor, you really should be using an engineer here. And that is true in the context of fall protection. Competent person, 16 responsibilities. That's your site level guy, your foreman, your shop supervisor that's going to be overseeing this work. Hopefully that, in a quick nutshell, builds enough elaboration. Yes, ma'am.
Online, I think we're going back, but how do you secure the cover without damaging the floor?
Good question. You know, I use the term or phrase secured from displacement. Secured from displacement. That doesn't necessarily mean secured to the floor, does it? Like directly fastened to the floor. It means secured from displacement. And by the way, there are a variety of products on the market that essentially use, I don't know how exactly to describe this precisely, but you have the floor hole cover, and integrated within that floor hole cover are some posts, if you will. And those posts drop down from that floor hole cover and wedge themselves into the floor. Now, that's secured from displacement until it's not, isn't it? And that not might be through construction activities, it might be wind, it might be something like that. So, you know, these regulations that we follow oftentimes are very permissive in nature. Anytime you see the term like adequate, sufficient, secured from displacement. Well, that's subjective to the environment. So for a qualified person to design a proper cover, they need to take those environmental factors into consideration to assure nothing will uplift or relocate or remove that floor hole cover. It doesn't necessarily always mean drilled down, secured to the deck. Some cases it might though. That's up to that qualified person. Yes, ma'am.
Two more questions?
Sure.
Wants a suggestion here. Where can you purchase those yellow base corner brackets that was a 4x4 corner?
So there's a variety of fall protection suppliers out there on the market. 3M makes a whole line of them, as does 3M, by the way, DBI Solid, Capital Safety, all those guys, Miller and Honeywell, Protecta, Rebel, that whole line. They do make products. Guardian as well makes a whole line of base stanchions like what you see in this photograph right here, to include floor hole covers, safety nets, skylight protection nets, whole multitude of stuff. Guardian has quite the wide range of product offerings that are on the market. Yes, ma'am.
Are toe boards required on both outside and inside edge of a scaffold when set within 14 inches from the wall?
No. Toe boards, so in California specifically, toe board requirements are based upon the exposure when it comes to a scaffold system. Now, on a building or a structure, let's consider this a building, some sort of structure, as it is. Toe boards are always going to be required. And consequently, we're going to look at our guardrail system as just that, an overall system comprising of a top rail, mid rail, and a toe board. That's unique to these unprotected edge, static edge environments. That might be around an elevator shaft, around the edge of a roof, or some other unprotected edge location. On a scaffold system, it is exposure based. In other words, if there's a exposure to human beings being underneath that piece of scaffold equipment, and there's a potential of a dropped object injuring that human being, well, then we need to have falling object protection. Falling object protection doesn't only always mean toe boards. There's other ways to protect workers from dropped objects. It might be nets. It might be containment on that scaffold system. Because sometimes toe boards aren't sufficient enough. Toe boards are only 3.5 inches in height. You got objects piled higher than that toe board doesn't do anything for us. And consequently, additional requirements will come into play here. So specific to that 14-inch dimension that was mentioned, the reason that the question and the context was for 14-inch is because on a scaffold system, and again, this is specific to scaffolds, not other walking surfaces, when the inside edge of our planks are within 14 inches of that solid face work surface. So if this is my solid face work surface, here's the inside edge of my planks. If we are within 14 inches, there is not a requirement to maintain a double set of inside guardrails. And if you read the regulation, essentially what it says is toe boards are going to be required on railed scaffolds. Railed scaffolds. Therefore, if it's guardrail, it's going to get a toe board. Consequently, if we're within 14 inches of that solid face work surface and we are not required to install guardrails, then we would also not be required to install toe boards. And one thing to keep in mind about scaffold systems and inside toe boards and stuff like that, frankly, I appreciate the desire to try and address dropped objects on scaffolds like this, but do understand there's some implications there. Because a worker working on a scaffold system, when you have that toe board in front of you here, it's going to push your feet and your hips back. It's going to require you to lean forward and further. And so guess what happens to the worker when they work on this thing? They go screw it. They just step right on the toe board every single time. Every single time. And so then we got to ask ourselves, what are we really trying to accomplish with this toe board installation? Falling objects. Okay, great. By virtue of the fact that we have a scaffold system here, means that human beings are taking stuff in their hands and they're applying it to wall surfaces. Our biggest exposure of dropping objects at that point becomes what's in your hands, not what's on the deck. Tools, debris, material, metal stud clips, pieces of dense glass, a sheet of drywall or dense glass getting hung on the wall. You drop that, toe board's not going to do nothing for you. OODA loop. Observation, observing, deciding, acting. Same thing applies there. Good questions. I appreciate that. Thanks for everyone online for reaching out to us. If I'm not clear with any of this stuff, feel free to follow up. I'm happy to help out and answer. There's our tow board requirements. 50 pounds of force on a tow board. 150 pounds downwards or upwards force, down or out on mid rail. And 200 pounds of top rail force downwards or outwards. Again, qualified person design. Manufacturer in a box. So what I mean by that is you go buy those nice little plastic stanchions that have already been designed and rated for that installation, and you install it according to their requirements, and there you go. You've got a guardrail system. Let's move on down. We're going down our hierarchy here. So we just saw some passive systems. Let's start going into our active systems now. Restraint specifically. Gee, you saw it on that slide with those green and yellow red bars, and now you're seeing it here going down my hierarchy. And interestingly, I have fall restraint, like we see with these performers here. This is, by the way, at Disney California Adventure. I was walking through the park with my family last year or so, and Chinese New Year was going on, and they had a parade float going by. This parade float was about 5 or so feet above the ground, moving naturally. I saw that and I went, oh, how cool is that? They've got a restraint system up there, don't they?
Yeah.
2 individuals tied off with a short lanyard to that post. Good solutions. Why is fall restraint more preferred than fall arrest? Because going through my hierarchy here, I have fall restraint as being more preferred. Why? Keeps you from going over the edge. So if nobody falls because restraint keeps us from falling over the edge, what does that mean for us?
You still get injured.
Even with fall arrest, people still get injured, don't they? They fall, they contact objects, they hit things on their way down. You bet. What else does that mean? There's one other really important aspect to this too.
Disruption.
I'm sorry?
Disruption.
Disruption? Yeah, that's part of it. Yeah, no fall, no disruption to the job site. Not a bunch of people freaking out. All the paramedics. Which really means no rescue. No rescue required. There's no fall, no rescue. Also, our anchor strengths that are required out of fall restraint are lower than what they are for fall arrest. You're going to see that here coming up. A couple good things going on with restraint. As opposed to fall arrest, yeah, we've got rescue to deal with. We got that potential injury that might occur. And not to mention this thing right here. Orthostatic suspension intolerance. Having a human being hang in an industrial harness for long periods of time is not a good thing. Talk about that here in just a moment, but it is dangerous. Continuing down our hierarchy, this is going to be the last form of control within this concept of conventional systems, and that's safety nets. Safety nets nowadays are not something that you see as a primary form of fall protection. It's starting to become more of a secondary form, and not only just used for human fall protection, but also for falling object protection as an additional benefit to that. Seeing these a lot in a variety of different environments. You'll see that here coming up. A lot of things to pay attention to with these safety nets. My suggestion, go to Guardian, go to 3M, buy a proper safety net for that environment, install it according to their instructions, and you're done. No need to do these drop tests and all these different things that are written into the standard. But you do need to pay attention to the net deflection. And as you see in this photograph here, once humans end up in those nets, they do deflect quite heavily. And if that net's not set high enough, somebody falls into it, they're going to strike that ground if we're not paying attention to that deflection that occurs. And manufacturers do address this in their literature, of course. So here's what I was talking about. As far as our combination of systems that are being used. This is one of our scaffold jobs that we did. And I guarantee nobody in this room probably recognizes this building. But as soon as I tell you what it is, you're probably going to be on the side a little bit. You know that high-rise building in downtown LA that's got all that lovely artwork on the outside of it? Oh yeah, that's this one. That's this one. And yes, we are still owed large sums of money on it, by which hopefully we will see someday. Yeah, it hurts. Every time I see it, it's like, oh, you got me. You got me. What can you do? You know, almost $1 million in labor just to remove it. So it sat up there for a couple plus years before I decided to come and tear it down. But we have a combination of systems going on. Up at the top, we've got that cocoon system, falling object and fall protection. that gets hydraulically jacked and moved up with the structure as it's erected. We've got safety nets installed just below the cocoon system for those dropped objects and human protection. Below that, we have netting, not just toe boards, but guardrails and netting. And then, of course, we have such a lovely, beautiful scaffold system that's been erected as well. I kind of know a company, you know what I mean? Continuing down our hierarchy, warning line systems, controlled access zones, OSHA written fall protection plans. That's a whole broad concept, again, that we could spend many hours just talking about in and of itself. But broadly speaking, control lines, controlled access zones, and warning line systems appear very similar from their physical features. What differs is their application of use. So warning line systems are for roofers performing roof work. Controlled access zones are available to be used where there's leading edge work, where conventional systems are infeasible or creates a greater hazard. I use that term because that's from the regulation. I hear people in the industry say that. Oh, they don't have to tie off because it's infeasible. Okay. When somebody says something like that, what they're saying is they don't have to tie off because tie off is impossible. You know, 20 years ago when I got into the industry, that was probably true. All we had were, well, I mean, in my company, we had body belts and straight rope lanyards with non-locking snap hooks. And we used them on job sites where we were told, hey, there's a safety guy watching you, so use this and tie off to something. We're like, okay, is this really gonna help us? They're like, no, but just tie off anyways. And we're like, okay, so don't fall is what you're saying. Yeah, definitely don't fall. You won't be good. Some of you guys are grinning because you got enough gray hair like I do to show that you've been there as well. It's quite lovely. Warning line systems get delineated 6 feet back from the unprotected edge, flagged at 6-foot intervals, fall between 34 to 39 inches in height. And one of the big things that I tend to see that's the biggest issue is this right here, this line breaking strength requirement. I can't tell you how many times I see a warning line system being installed out there and regular danger tape is used. Does regular danger tape give you a 500-pound breaking strength? Yeah. These be nice, durable, suitable materials. And again, there's a variety of companies that make these products out there ready to go for us. And of course, we can't go within this exclusion zone like we see this gentleman here. As soon as we cross that warning line, conventional systems are required, conventional fall protection. Because at the end of the day, a warning line is just a visual indication of something unsafe. It doesn't stop a fall. It's just, hey, don't go past that line, it's dangerous. That's all it does. Now your control lines, like I said, look very similar. The difference is that with a controlled access zone, we must designate a safety monitor. That should sound familiar. We shall have a written fall protection plan to back up that work process. And these types of controlled access zones are only available for residential construction, leading edge work, precast concrete erection, or overhand brick laying, all of which describe specific work processes. Safety monitors are a key part to that, however. Let's get into some of our training requirements. This is general industry training requirements. Now, believe it or not, it wasn't until 2018 that there was a regulatory standard that mandated workers be trained in falls for general industry. That's crazy when you think about it. Under the 1910, there was no specific standard related to fall protection that mandated worker training for fall protection. It existed in construction for many years. What was happening? Well, statistically, when we look at falls across the board, what really sucks about this whole thing is per capita, our rates of fatality for electrocutions, dropped objects, caught in betweens. Oh, sounds like our focus 4 that we're getting to, huh? Statistically, we've seen slight reductions in those fatal injuries year after year after year. Sometimes I'll have a little take up of a year, but generally speaking, it shows there's progress being made out there in worker safety. But that's not been the case with falls. Falls in construction have remained static. They flatline. Still to this day, roughly 37% of worker fatalities are from a fall. And that's been the case since I got into this industry 20 years ago. When are we going to get better? That's what I'm wondering. With all this great product education, programs out there. We're not doing it yet. General industry, what was recognized? Those rates of fatal injuries because of our logistics warehouses that are out there started to have a slight increase in fatal falls. And that was become noticed in the early 2000 teens within OSHA. So that prompted some regulatory changes that ultimately culminated with that 2018 change that we see here. Construction, train these folks. They got to be able to recognize fall hazards, know how to minimize them, know how to deal with them, and know how to come up with the proper system for that environment. And I do wish we had more time to really unpack the topics that are here, but as you can start to see, fall protection, it's so funny to me because I'll have students come in the first day, fall protection is 3 days, it used to be 4. And they go, what in the hell are we going to talk about for 3 days? And I just think, are you kidding me? I sit around and think what I'm not going to talk about for 3 days because there's so much to go over. It's unbelievable how wide and far reaching this concept is. So again, this is just a quick overview. Let's talk a little bit about our ABCs of fall protection. You've probably heard this before. ABCs, anchor point, body harness, and connecting systems. Now, our anchors, we're going to look at 2 broad different ways we're considering anchors. And what I mean by this, on one side, we're going to have anchorages. That's the structure. That's the part that we're tying something to. And then we're going to have anchorage connectors. And those anchorage connectors look stuff like this. We have our sliding beam anchors. We have our concrete anchors. These are called type A multi-use anchors. Multi-use because they can be removed. They can be relocated from place to place to place to place. These concrete anchors, like you see here on the right, they can be relocated to another hole. These things are really, really cool. Couple things to look out when you're using a concrete anchor like this. They do look like a little wedge anchor at the end if you've ever used a KB3 quick bolt or a redhead that were common for a concrete anchor, very similar to that. Most of them only require 3,000 PSI concrete. 3,000 PSI concrete is builder's grade concrete. That's like pretty much everything except for some lightweight roof decks and stuff like that. Require only about 1.5 to 2 inch, depending upon the manufacturer, of a hole that gets drilled 3/4 inch size. You drill the hole, and you don't blow the hole out anymore, do you? Once you drill that hole in concrete, go get your air compressor. No, you don't do that anymore? Oh, thank you. HEPA, of course, naturally, yeah, of course. Silica exposure, can't do that. Can't do that. And once you got the nice clean hole, you drop that anchor in and gives you a 5,000 pound attachment. They even got 10,000 pound anchors. 10,000 pounds for horizontal lifelines where there might be up to 4 people attached to 2 different anchors simultaneously. Our synthetic straps, cross arm straps and the like, these are type T anchors. Your type T anchors are designed to have things like a Esser rail hanging off of it. And of course, you can attach a 6-foot lanyard or stuff like that too. Very ubiquitous, very universal, easily relocatable. That's the benefit of your cross arm straps. And cheap, not very expensive to buy. Cast in place cross arm straps, just as it sounds. An anchor that gets casted into concrete gets wrapped around rebar. That anchor protrudes through the concrete formwork. Concrete gets poured, forms get broke, and now you have temporary tie off until the wall systems go in place. Once the wall system's right there, we don't need fall protection anymore. Take a razor knife, slice off that polyester. There you go, done deal. A lot of options out there in this industry. Another classification of broad anchors we see out there, anchorage connectors to be exact, are our type B anchors. And these are deforming type anchors. These are the anchors that when attached and there's a fall load exerted on it, they do deform. They're non-reusable. And that is the case for most of these anchorage connectors. Most are non-reusable. Some are. Very few, but some are. Got to look at the manufacturer instructions. Here's our capacity requirements for our anchors that we identified. Fall arrest, of course, 5,000 pounds. Unquestionably strong. I love this term, by the way. The reason why I like it, because this whole concept and this term, unquestionably strong, comes right from that Z359.1-2020 standard. Unquestionably strong anchor. 5,000 pounds is a lot of weight, isn't it? What's 5,000 pounds look like? Don't say your mother-in-law, man. That's not cool. Oh, I love my mother-in-law. She is a wonderful lady. F-150 pickup truck, short bed, extended cab, F-150 two-wheel drive pickup truck weighs just about 5,000 pounds. So what I like to tell folks is if you are willing to take that F-150 pickup truck and then attach it to something structural, and then you're willing to stand underneath that truck while it's suspended in the air, go ahead and tie off to that. If you can't envision that in your head, you do not have an unquestionably strong anchor. So 5,000 pounds for fall arrest, 3,000 pounds for positioning systems. Positioning, by the way, think of like a lineman climbing a power pole. Subpelvic rings get attached to that adjacent structure, bringing up the hands, allowing for that work positioning application. Look at that, restraint systems, only 1,000 pounds, because we're only trying to generate enough force to stop the human from walking forward. So very minimal anchor strengths needed out of restraint compared to fall arrest. That's one of the many benefits of restraint systems. Rescue systems get 3,000 pounds of capacity. And anyone have any idea why I have not applicable for horizontal lifelines? Competent person, non-certified anchor, competent person, non-certified anchor, not applicable for horizontal lifelines. That is because all horizontal lifelines shall be designed by a qualified person, an engineer. You got it. You got it. By a qualified person, meeting a 2-to-1 safety factor. And you know what? For you folks that have read a regulation that says all anchors must carry 5,000 pounds or meet a 2-to-1 safety factor as part of that complete system, take my 3115 fall protection course so I can explain a little bit more what that second part means. Because that part is the part that a lot of folks miss. They don't understand what that 2-to-1 safety factor means and how it comes into play. Anchors are classified, non-certified and certified. Roof bracket anchors, wood anchors, man, I cannot tell you how important it is to review the instructions for installation for these types of equipment. The expectation of use, the number of fasteners, the types of screws, the types of nails, the substrate types, all vary dramatically. Never more do I see more variance in what manufacturers expect out of these devices than I do with wood bracket roof anchors. Your solar installers, your roofers. So many structures down in Camp Pendleton I'm thinking of that are old buildings built in the 40s and 50s. Workers having to go up there and tie off to something, and they're using these things all over the place. They're very easily misused. Weighted anchorages or ballasted anchorages, these are available. I mean, there's so many different things on the market. It's mind-blowing, and we're not even scratching the surface of some of this stuff. Yes, it uses steel weight or water to provide and generate enough friction between that surface and preventing somebody from reaching that unprotected edge. Most of them are restraint applications only. Not all are rated for fall arrest, but there are some out there rated for fall arrest. Do pay attention, these things cannot be placed on rock aggregate roofs, clay tile roofs, slope roofs. For obvious reasons, gotta have friction there. You set the thing on a bunch of rock aggregates on that roof, slow ball bearings underneath that thing. It's gonna slide right off the edge of that roof. Vacuum pad anchorages. Just as it sounds, this DBI solid multi-lock system right here uses compressed air. That compressed air goes through a venturi. On the backside, the vacuum is generated. There's very sensitive indicators on here with the gauge and an audible warning device. You hear that? Don't fall. I'm kidding. But seriously, don't fall. Address it. These things are great. Manufacturers have specs for epoxy painted surfaces, so think concrete water tanks, steel water tanks. Aerospace manufacturers. I worked with a contractor, I consulted with a contractor, I worked at Northrop Grumman that would use these inside of their vacuum chambers. Can't drill any holes or weld anything to a vacuum chamber, but you can suck one of those things to it. A lot of options out there. And if there's anything to take away from some of this stuff is that idea of impossible tie-off, you're probably starting to see it's not very good justification. And when we look at our common structures and locations of tie-off, we need to avoid our conduit, our vent pipes, our HVAC systems. We need structural components. And the strongest point of any truss is going to be right where those truss cords all come together. All three of those cords come together. That's going to be the strongest point. Some sharp edges in there to pay attention to address. This is a basement of a random hospital. I don't remember which one they took a photo of. But there's a lot of things that we should not tie to, right? How about this unistrut? Are we tying off to this unistrut here, holding up the effect upward? Why not? Is that gonna hold your, truck, F-150 pickup truck? Of course not. How about this insulated pipe? Are we tying off to that, this white piping in here? How about this cast iron pipe, the no-hub couplings in here, the water pipes? Tying off to that? Structural in nature. If it's holding up a floor, a building, it's holding up walls, that's the kind of stuff that we're looking for. Big concrete columns, large steel beams. We want something that you look at it and you go, holy crap, that thing is so freaking strong, it's even funny. That's the kind of stuff that we want to tie to. Any questions online yet? Any further questions that have come through online? No? Okay. Yes, sir. We have a question here in the room. We'll get you the mic.
A worker is on a scissor lift work on brackets. Where should he tie it to?
Great question. So scissor lifts, let's talk about the OSHA requirements, and then we'll talk about kind of common industry procedures that I see out there. OSHA does not require workers to tie off on a scissor lift, provided the guardrails are intact, in place, full height, and fully erected. Now, scissor lifts are not aerial lifts. Aerial lifts are your boom lifts, your lifts that essentially move that carriage away from the base of the lift. Unquestionable, use restraint inside those. Not arrest, but use restraint. I'll explain why later, but do understand, use restraint inside of an aerial lift. Don't let yourself get ejected out of that carriage. Scissor lifts, vertical platforms that go up and down, do not require tie-off by regulation. However, it's common for contractors to mandate it. So the question is, where do I tie off? Well, the manufacturers of modern lifts, manufactured within the last 7-8 years plus, they give designated tie-off points, and they're usually located either in the center of the floor. Sometimes they're around the mid-rail in one of the corners, or even near the control panel that you use. You'll have a couple designated rings there. Now, part of our lift devices, scissor lifts, aerial lifts, isn't it required that we maintain something on that lift, like a document or something like that? Yeah, that's right. Yeah, we got to have that form on there, the inspection form contained with the manufacturer instructions on that lift. Now, the reason I point that out is because the manufacturers of the lift will identify where those specific attachment points fall, because they do vary depending upon the lift quite a bit. So I see a lot of contractors, like I said, mandating tie-off inside scissor lifts. And if you do, make sure the lift you're renting or buying has those attachment locations, because there are older ones that don't have those attachment locations for scissor lifts because it hasn't been a requirement. Does that answer your question, sir? Thank you. Let's move on to body harnesses. Arc rated, high vis, flame retardant. Yes, there are arc flash rated equipment. There is flame resistant rated body harnesses. Where there's been a need, the industry has responded. And that's what we see with stuff like this. Personal flotation devices that get integrated, tool belts that get integrated. There are so many options out there. It's absolutely mind-blowing for the different ways in which we can provide a scaffold kit, a roofer kit, an industrial harness for somebody working in a coker plant, all unique to those environments. Now, when we put these harnesses on, I see a lot of folks misapply how they're donning their harnesses. And step by step, it's crucially important that we follow these sequences. Now, this sequence right here came from Miller. 8 easy steps that can save your life. And it's quite remarkable how many people forget how to properly put on a body harness. And it's not because they're lazy or just, oh, I want to loosen up the leg straps because it's uncomfortable. No, legitimately, they don't understand the correct sequence. There is a sequence to installing these things. And the reason for that is to assure that that body harness fits your body correctly. The location of where that dorsal strap intersects the subpelvic strap. That's important. The location and height of that chest strap, relation to your overall body, and the shoulder straps, also important. If we start adjusting this thing out of sequence, we mess with that geometry. So once we hold it by the dorsal ring, disconnect all the components, we put it on like a jacket. We secure the subpelvic straps first. This is where I see folks go wrong. Leg straps go first. Then chest strap, then we adjust for overall fit. If the body harness has a body belt, that goes last. But make sure those subpelvic straps are adjusted first. Snug, not tight. Should have enough room to get your fingers in there, but not extra space than that. And for your shoulder straps, you should have enough room to get your fists in there, but not a lot of extra room beyond that. Overall, nice snug fit. No keys, knives, things like that in your pockets, all that stuff comes out. Jackets can go over the top. Got a little slot in your dorsal ring. The dorsal ring can shoot through. Inspection of our equipment. Proper good function, no rust, no corrosion, no dragging of the gate. And what happens to these devices, especially our carabiners, is they get dropped and the body hits the floor and now it tweaks that gate just a little bit. And now that gate doesn't slide close smoothly any longer. All of our connecting systems, whether it's a snap hook, carabiner, shall be self-locking, self-closing. If they're too gummed up, dirt, grease, whatever it might be, we need to clean them. If that doesn't correct the dragging issue, we dispose of them. When in doubt, throw it out. Don't go to Home Depot and buy a carabiner from the checkout aisle. That barely holds your keys, let alone 5,000 pounds. Compatible connections. Don't do any funky things with that snap hook, binding that snap hook on the side, pulling at it at an angle, loading the gate incorrectly. I'm sure the folks online can see this cut out fairly well. Maybe some people in the back have a little trouble seeing it. But ultimately, what we're avoiding is no gate-to-gate connections. We see a lot of situations out there where somebody has an SRL attached to something over here, and they realize, damn, that SRL is too short. So what do? They go and get a lanyard, and they attach it to that SRL, made it just a little bit longer. Now, to do that means that they had to connect two snap hooks together, gate to gate. Don't do gate to gate. We do not want to see that. That will bind those gates and potentially load them in an orientation they're not designed for. So gate goes to solid. If you can remember that, you'll avoid a lot of configuration problems that we see out there in the industry. Same thing applies to these large mouth opening snap hooks as well. No gate to gate. A lot of different style lanyards out there. Fixed restraint lanyards, adjustable types. These are not for fall arrest. These are only for restraint. Double-legged, single-legged, pigtail extensions. The problem is you start injecting so many different products into your environment that people become confused as to what's appropriate to be used. I suggest what you do is you analyze those exposures and then come up with like a kit, your standardized bucket kit for most of those exposures, and then keep OODA looping them and determining whether or not that solution you provided is in fact working. Because you start SRLs and leading edge SRLs and lanyards and all this stuff and rope grabs. Next thing you know, you've got a daisy chain, a lifeline that's 200 feet long. I've seen it. Some standardized processes that recently changed as well. Black label white writing, white label red writing. 6 foot free fall lanyard, 12 foot free fall lanyards. Personal fall limiters. So now we're starting to get into, in a couple slides, we'll get specifically to what's changing here. But let me show you some of these broad scope classifications of these SRDs, and then I'll tell you about what changed recently in the standard here. These are personal fall limiters. The reel goes to your back. The lifeline goes to your anchor. This on the right is your leading edge type personal fall limiter, where the reel goes to your back and it can be used for foot level tie off. Notice that pictogram that you see on the right, that little hard edge. That's to indicate to you that it's of a leading edge type. Assisted rescue devices, those are called SRLRs for retrieval, all of which fall under this umbrella classification. So let me touch on this leading edge concept here for these types of SRLs. And what happens if you do not use the proper SRL for the right orientation? And this is a drop test that's performed by one of my buddies here. Are you able to hit that? Oh, sure. So drop test, this is a non-leading edge type SRL being used in a leading edge type configuration.
Right, David, on top? David, there's no, David, can't be. I think there's no shop. On this doesn't.
So this is a drop test leading edge with no shock pack.
You guys ready?
Yep.
Okay, we're good to go. I'm gonna drop. Headache.
Wire rope cable that.
Go ahead, don't use a shock pack.
Did you get that?
Sure did.
I wasn't, you were.
That was wire rope cable severed like a hot knife through butter.
Can you replay that?
Sure, happens fast, doesn't it? Again,
Right, David, on top? David, there's no, David.
designed for overhead applications only. Being used in a leading edge configuration.
Can't be. I think there's no shop. On this doesn't.
So this is a drop test leading edge with no shock pack.
You guys ready?
Yep.
Okay, we're good to go. I'm gonna drop. Headache.
That stuff happens. Just a couple of years ago, an iron worker in Pasadena was killed when he had a personal fall limiter tied off at foot level. And he was on his knees trying to weld a column, and that device was not used for designed for a leading edge application. He fell over the edge, fell 18 feet to his death. Happens all the damn time. That's part of what prompted ANSI to create some of these regulatory changes that we see here.
So Jeremy, remind me, how can you tell if it's designed for leading edge? Is it indicated on the tag? Or?
Yes, and in fact, we're going to get to that in just a couple slides here. I have some new classification. It's not my classification, but I have things to show you that ANSI recently updated that makes this a lot easier for us to identify our class types and whether it's designed for leading edge or non-leading edge work. Because here's what happens when we have a proper leading edge device.
Okay, so this is an actual test with a shock pack.
You guys ready?
Yep.
3, 2, 1. Hey, that's a better result. Yeah.
Notice the shock pack doesn't come out all the way. Much better though with a shock pack.
Is that 250?
So clearly there's a marked difference between the two. Now, what we see here, kind of going through less dramatics as we see these various videos, is a drop test being performed with a 6-foot shock absorbing lanyard, 3.5 feet of deployment, additional free fall as a result of it being a 6-foot lanyard. Those get tied off at shoulder level or above. And here's an SRL drop test. You're going to notice with the standard vertical type SRL, the locking occurs very rapidly. So there's not much free fall and consequent arresting force involved. Almost immediate locking of the device. And that's what these devices are really intended for. These overhead vertical type SRLs are in environments where we don't have much fall clearance underneath us. They really reduce that total fall distance to a level that's acceptable. And as we go through our various classes of SRLs, getting into our leading edge and shock absorbing lanyards, our fall distances increase accordingly. So you see we color coded the chart here to depict the deceleration distance, height of the D-ring, harness stretch, swing fall, and safety factor built into it in one. And that fall distance will range anywhere from about 8.5 feet all the way out to 30 feet. And it just depends the type of systems that you're using here. Orthostatic suspension intolerance. Rescue issues and rescue considerations. By the way, we're going to get to that class thing. I haven't forgotten. It's just at the end. I have a little bow for our Z359 updates here. Orthostatic suspension intolerance. There's been a variety of studies that have been done through the years to analyze what happens to the body and also view statistics associated with post-suspension trauma related problems. And broadly what's happening here is we have a constriction of our femoral arteries. So there you are hanging in a harness and those subpelvic straps are cutting into those arteries. We're creating restriction in blood flow. And now we have blood pooling in our legs. That blood is still being used. Metabolic processes are generating waste and specifically lactic acid. And so now you have this buildup of lactic acid laden blood. for lack of a better description, let's call it stale bad blood built up into your legs. And when you release that constriction, the human can suffer something called lactic acidosis. And it's not unsimilar to blood poisoning. Your body cannot deal with that pH imbalance of inrush of blood in such a significant quantities all at once. And primarily, it begins to affect the kidneys, the liver, and systematically your organs can shut down as a result of that exposure. Now, statistically, really and truly, that concern of suspension trauma is somewhere between 45 minutes to an hour, where that intolerance can become quite significant. I hear trainers go, "Oh, 2 minutes and you're dead." Well, that's not really true. But what is true is that within a couple minutes, the human body is going to realize what's going on and try to deal with that suspension trauma by increased respiratory rates, increased cardiac rates. And I had a jujitsu guy in here earlier. When you put a rear naked choke on somebody and you attack those carotid arteries, you're not attacking the airway, you're attacking, you watch it UFC or something like that. That person goes to sleep because you're attacking the carotid arteries. It's due to a restriction of oxygenated blood going to the brain. Similar things happen when you're in that body harness with that constriction, a lack of oxygenated blood flow going to the brain. Here you are hanging in a harness. What happens to your head? Exactly. Falls forward, constricting the airway, compounding the problems that we originally had of oxygenated blood going through the system. So it is certainly a problem and certainly something that needs to be addressed, which is why rescue is so important. High angle rescue, assisted rescue, self-rescue, and elimination systems are the ways that we look at our rescue processes. Self-rescue, ladder deployments, SRDs that have integrated self-braking systems into them. So when the worker falls, the SRL locks and then automatically lowers the worker down to the ground. Beautiful systems out there to address our rescue problems. The Guardian rogueless for assisted rescue. Our self-descent systems built into this solid pack right here comes with 50 feet or 100 feet of rope. And you can see this tab that the gentleman's pulling on. As soon as he pulls that, it lowers him down to the next lower level. Very cool stuff out there. But before you get in all these fancy devices and all these different things here, think simple first. Does a ladder work? Does an aerial lift work? Does a scissor lift work? Maybe your solution is to break a window and bring that worker in. Think simple, think quick, and then consider the exposure for the rescuer as well. Because if you break that window to pull that fallen worker from the outside of the structure into the building, you just likely create an additional fall exposure for the person that's doing the rescuing. And now you might have 2 people to rescue. Definitely things to think about. Any last questions before I move on to our Z359 updates? There's only a couple things here to address. Yes, sir. Can we get him the mic?
Does body harness manufacturers would do say something like you can only use it with their brand of connectors?
That's a very, very good question. So the cross compatibility across manufacturers generally is not an issue. So it is acceptable to take a Guardian anchorage strap with a Miller SRL and attach it to some other manufacturer's body harnesses. Broadly speaking, what the issue here is that we want to make sure the connecting systems are compatible with one another. Nice, good, clean engagement with the proper loading orientation. We don't want to take like that twin nano lock, that little PFL, the orange device that I had here on the slide, and then connect that to a 6-foot shock absorbing lanyard and then attach that to the harness. You know, brand doesn't matter at that point as much as is it equipment being used in the correct orientation. I've not seen a manufacturer yet strictly limit their components to only that manufacturer type. I've not seen that yet. Yes, online questions.
Yes, it says anchor points that can be bolted onto a wall, do they have to be installed by a qualified person?
As long as that anchor is already designed by a qualified person. And I know that sounds like a circular answer, but here's what's going on. If a user is going to take an eye bolt that's not rated for fall arrest use, some off-the-shelf eye bolt, and then install it into that wall, that needs to be designed by an engineer. But if you already buy an anchor, a wall anchor from Miller, from Guardian, from Falltech, and it's already been designed for that use, well, that is your qualified person design. You have a properly manufactured anchor with the instructions behind it, then a competent person can do that installation for that anchor following those instructions. Yes.
You mentioned ladder safety systems, didn't you? What do you think of them?
I think that somebody should open a ladder safety system retrofit business here in the next couple of years, because there are some significant changes coming down the pipeline for permanent fixed ladders in our workplace. That's what I think. Now, ladder safety systems have a purpose, and broadly speaking, I would prefer they get used out there in the industry, but like most things, it's a cost-saving effort for most organizations. So I can speak about my own personal ideals. Whether or not that meets reality is another thing. One thing that is true is that cages around your fixed ladders are only resting devices. They don't stop you from falling. And so the purpose of a cage on those ladders that we see out there is to allow you to lock your heels into the rungs of that ladder and then lean back on that cage, resting your legs, resting your arms. Because otherwise, if you fall, the only thing that cage is going to do is make sure that you splat down at the bottom of the ladder and not 10 feet away from the ladder. Otherwise, the cages functionally don't do much of anything, just rest. So 2035, OSHA has proposals that they plan on mandating all ladders be retrofitted from cages to having an integrated ladder safety system. That's why I made the comment. You got about 10 years or so before the demand for ladder safety systems shoot through the roof. There you go. Any others online? Okay, cool. Let's take a look at our Z359.1-2020. Point 14. Point 14 is our SRD requirements, self-retracting device requirements for all SRLs. They've been completely reclassified. So the question of being, well, how do I know it's a leading edge SRL? Well, that was part of the problem, was that it always wasn't really clear whether or not the device you purchased was a leading edge SRL. It should have said something like SRL-LE for leading edge. It should have had some sort of pictogram, like if you recall that nanolock that had that triangular shaped pictogram with the line going, that would indicate it's a leading edge type SRL. However, there was a lot of inconsistency out in the industry. So that prompted some ANSI changes that are here. Now we have three main broad scope categories of all SRLs. We have SRL-Rs, standing for retrieval. Notice it has a crank arm on it that's designed for the lowering or raising of employees. Maybe you might use something like this on a tripod for confined space injury. You could also use these for rescue processes as well on a davit arm to pull somebody up and rescue them to a structure. We have SRL-Ps, standing for personal. That's the personal fall limiters. I call them PFLs, where the rail goes to your back. And then lastly, broadly speaking, we have all other SRLs, and that includes both vertical type SRLs and then leading edge type SRLs. Now, what these changes did recently went into effect of August of last year, 23. The intent was to make some of that classification a little bit easier, make it more clear. Is this a leading edge type? Is this a non-leading edge type? That was primarily what drove a lot of this. Also, it changed some of the safety factors, some of the post-hang suspension load forces that these systems have to sustain. And it standardized labels and markings that didn't exist before. So for this new requirement that just came into play here, do I have to change my equipment? No, you can keep using your equipment provided you use it correctly. There's no need for you to go get rid of your SRLs and start buying new stuff. Just know that these are changes that when you buy something from a manufacturer today, you should see this out of that manufacturer right now. Have the arresting distances changed? Yes, the fall arrest distance changed. And what basically happened is we had type A's and type B's prior to this. And your type A's were your vertical type SRLs, had a 24-inch, 2-foot free fall locking distance. And then your type B's were your leading edge type up to a 54 fall distance that we had. Now, all of our class SRLs have a 42-inch maximum free fall distance, or deceleration distance, I should say, associated with them. And then, yes, we do have some new labels that we will be looking for. Here's the best part about it. Contrasting labels. Stupid easy, black label white writing, again, and white label black writing. Your class 1s, Those are your vertical type SRLs. Those get attached at shoulder level, at dorsal level, or above. And you'll see a nice square white label on that SRL device. Your class 2s, black label, white writing, those are your leading edge types. They get tied off virtually anywhere, foot level, shoulder level, above. So you'll see this symbology now on all these new leading edges that just make it very, very easy for anybody to identify. You walk up, look at the label, bam, there you go, class 1, class 2, and you know how it's to be used. Categorically speaking, just kind of as an aside, your class 2 devices, which you will tend to see, are 2 physical features on that device. One is going to have an integrated shock pack somewhere on that device. It has to, because you're tied off at foot level and you're going to free fall some distance, and then that system's going to lock. It has to dissipate that energy. So generally speaking, on your class 2s, you're going to see an integrated shock pack, and then more often than not, it's going to be wire rope cable that forms that lifeline, not synthetic materials. So those are 2 good indicators. Even from a distance, you can tell whether or not it's class type just by looking at it. And lastly, the warning label. Every device comes now with this warning label. You know, some manufacturers out there had some issues with their arrestor deployment with their SRLs that they had designed. And so some additional recognition was needed. And primarily what's happening here is you tie off at foot level as opposed to above your head. The biggest concern that we start to face now is that total fall distance. Somebody going to contact the ground, going to contact another level or some object down below, because our fall distance does now change as a result of that foot level tie off. And then lastly, on your class 2 devices, your leading edge types, you're going to see now some additional labeling that's being provided that gives us our working distances, how far back from the unprotected edge that device sits, and how far off access angle that device may be. Because it's not just a matter of having the device set back from the unprotected edge and having the worker directly in line with that anchor at the edge of that structure. There will be some amount of offset, and all these devices have a maximum designed offset between where that device can be used in the worker. So these 2 charts that are now standardized as part of the 0.14 standards are something that you're going to see. So some kind of cool changes. And man, I'll tell you one thing about this industry that personally I like. We get to drive the industry. Fall arrest companies, users of the systems, you guys are driving it, not OSHA. Who drove the silica standard? Yeah, industry did, but OSHA created the law, and then everyone around them went, oh crap, I got to comply. Global Harmonized System, GHS, who remembers that one? Oh my God, GHS, we got to comply, we got to update our sheets, they're no longer MSDSs, we got to do SDSs and training and all that. This right here is paving the way for what OSHA is even looking at and going, holy crap, we're still 30 years behind what industry is doing. There's a huge demand for this stuff, and the market's not getting any smaller, only getting bigger. It's really, really cool stuff out there. Are there any questions? We filled it a lot. Any in-person, online questions? We went through a lot, I know. But man, there's so much more to go through. Only so much in one day. No questions? You guys are easy.
Just a comment.
Yes, sir.
Something you just alluded to, but 2 sentences ago. OSHA standards, they're 30 years behind. Government standards, OSHA standards in general, those are minimum requirements.
Fair.
And good companies are always beyond that. Of course, there's whole management science as to the companies that are best run. They also in safety, they're best run too. They're way ahead of that minimum standard required regulations. That should give you some idea what kind of employer you're working for.
Right. 100% agree with you, sir. Absolutely. And it's very exciting to see industry push the limits, push the boundaries here of what's capable out there. Very cool. Thank you for your comment. Yes, ma'am.
Online, if these labels come off, does this render the device unusable?
It does temporarily, yes. If the labels are not there at all, we must replace the labels. And the reason why is manufacturers require, generally speaking, that these labels remain intact. And the beauty of it, I buy a lot of stuff from Miller, or at least I used to. They'll sell you new labels. You tell them, hey, I have this SRL, here's the model number, need some labels. It used to be like 35 cents. Buy a new label, slap it on there, re-inspect it by a competent person, send it back out into use. But yes, temporarily that device will need to be suspended. Yes.
Who is responsible to inspect your scaffold daily and is a signature required?
All scaffolds must be inspected per work shift. The person that inspects it must be a competent person. What company that competent person works for is virtually irrelevant as far as OSHA's context is concerned. Most of the time, we are a scaffold supplier, as you know. We erect our equipment, we tag it, and release it for use. All the subsequent inspections tend to fall on our clients who are renting that equipment for us. It's not unlike any other leased equipment. You go lease a scissor lift, the user who's leasing that equipment inspects that scissor lift. You rent a car from Enterprise, well, it's your car temporarily. You keep it safe while you're using it. Rentals of scaffold systems is not any different. We're happy to do that for our clients, but not everybody wants to go down that path, but we will offer those inspections as well. That's it, all online questions? Everyone's going, it's Friday, it is 2 o'clock. We like gotta. Yes, sir, all.
Thank you, Jeremy. That was a great presentation. I was looking at the schedule and I know that you have a fall protection, you have a couple of fall protection classes coming up. You have one in August, you have one in November. But, you know, I was wondering if you could tell people about your scaffold class that's coming up in July, because we seem to cancel that class a lot and it's a really good class. So can you tell people about that class?
Yeah, thank you for giving me that opportunity. It is true that 3085, we do end up canceling a lot, even though it seems like students are really interested in that course, but we tend to see low enrollment out of it. The feedback that I've gotten from our students has been overwhelmingly positive. And the reason is because it's a 3-day class. So on the first day, we go through a lot of not only the regulation, but what's standard practice out in the industry, a little bit of PowerPoint, a little bit of worksheets. I teach students everything from this is what makes a safe scaffold from a basic standpoint to how do you do a load calculation on a cantilevered scaffold system? And by the time you're done with my class, you will know how to do a math calculation associated with that cantilevered system. I do bring in scaffold models. I have 1/3 scale models of our equipment, and we're able to display that and show in real time what makes a safe scaffold, what doesn't, what kinds of things we need to look for, what makes a good plank, what makes a bad plank, because there's a lot of nuance there between good and bad materials. And if we start to see a lot of in-person classes, what we used to do pre-COVID, before we did dual modality, is I would always have a section for hands-on, and I would always take students out to one of my projects, one of my scaffold projects on the 2nd and 3rd day. If we do have students that are primarily in the room, I will bring my scaffold equipment. We will have the opportunity to assemble both a K-ring scaffold and a frame type scaffold. We usually do that at my office, which is no more than a mile from the school here in Gardena, where I have all my equipment. You can see it laid out in our racks, and then we actually get to assemble it together and tear it down together. And then, like I said, I really like to pull students out to the field. Right now in LA, I have about 600 active projects somewhere. And that means that more often than not, I can find something very local here where one day we can meet out, we can see my employees building the scaffold, tearing down the scaffold, and depending upon the timing, you might see some pretty cool stuff. You know, we did Star Wars Land, all that rockwork scaffold was ours. We've set scaffold on the Golden Gate Bridge for the stainless steel suicide nets. We've done some really neat things out there. So I'm sure we can find you a scaffold that's not just a 1 frame high shack build, as we call them. Thank you for giving me that opportunity, Raul. I'd like to see you guys. Scaffold's my passion. It's a cool craft.
Thank you. So lastly, I don't think we advertised that we were raffling a class. So we're raffling a class with a value up to $795. And so people online get to participate, people in person here. The requirement is that they have to be present, right? So we had about 260 people that signed up for this event. And I think we ended up with a total of 85, 90 people.
That's about right.
So Giselle's gonna go ahead and do that raffle. And but before she does that, just know that our next event is gonna be in June. That's gonna be the trenching and excavation safety stand down. So you'll see more information on that. And Go ahead, Giselle.
Raffling.
So in the order that everybody signed in, there was a number assigned to you, and we're gonna be spinning now. So if we're here, we'll, call out the name or type it in the chat too, but we'll be checking the list of who's online and who's a person. Thank you. Elhan Shirazi.
Oh.
Oh. We called out the rules.
Do it again.
Check the online.
We'll do it 3 times, and if that doesn't work, I'm just gonna come to the list and go like this. That's the person that's gonna win.
Andy Garcia or online?
He's
Okay.
gotta respond if he's online.
Andy Garcia.
Going once. Yeah. Did he respond?
Taking a nap.
Yeah, that doesn't count. See, if he's sleeping, that doesn't count.
It doesn't.
Yeah, this is Henry, but I wasn't here the whole class, so go ahead and continue.
Did you just say you weren't here for the whole class?
Yes,
Okay, so you want us to give it to somebody else?
well, I think it'd be fair, right?
Your call.
Man of integrity.
I don't know, it's your guys' choice. I'll take it.
You'll take it? Okay, congratulations, George. Thank you very much again for coming, and we'll see you on our next event in June. Have a good day.
Thank you. Thank you, buddy. Appreciate it. Let's go to me. We'll take a certain amount of time. All right. I remember you.
Okay. Yeah, yeah, so we have.
Oh, yeah, cool.
We have.